Namaskara Karnataka, welcome aboard. This is your Captain Shreyas, your physics master teacher, and today we bring to you the important second PU Dali important questions. Yes, we heard it from you, and you wanted more sessions on your second PU as well as KCT, and your preparatory or pre-board exams are going on right now as we speak, and this session will definitely be helpful. Tomorrow, day after, and even after that, you will have continuous session on the most important second PU questions. Yes. Yeah, Yaridara Fidu. Yes, please call all your friends. ನಿಮ್ ಜೊತೆ ಫ್ರೆಂಡ್ಸ್ ಅಲ್ಲಿ ಬೇಗ ಕಾಲ್ ಮಾಡಿ. ಎಸ್ ಹೇಳಿ ಶ್ರೇಯಸ್ ಸರ್ ಬಂದಿದ್ದಾರೆ. ಇಂಪಾರ್ಟೆಂಟ್ ಕ್ವಶನ್ಸ್ ಡಿಸ್ಕಸ್ ಮಾಡ್ತೀನಿ ನೀವು. ಸೊ ವೆರಿ ಸೂಪರ್ ಇಂಪಾರ್ಟೆಂಟ್ ಸೆಷನ್ ಫಾರ್ ಆಲ್ ಅವರ್ ನಮ್ಮ ಕರ್ನಾಟಕ students. Okay, so my name is Captain Shreyas, and I have been teaching for more than 13 years. And this year, I'm making sure that I use my knowledge, my experience, and my entire team's efforts for ensuring that our Namma Karnataka students do really well, not just in PU, but also in KCT, and if you're also preparing for Comet K. That is the reason why we started this channel, and that is our sincere aim, and we really hope all these sessions prove to be very fruitful. So it means a lot. Yes, when you share this, when you like the video and subscribe to the channel. Okay, so thank you for liking, thank you for sharing. ಬೇಗ ಹೇಳಿ, ಬೇಗ subscribe ಮಾಡಿ, and ಬೇಗ like ಮಾಡಿ, because it is super duper important for all of us. Okay, so let's begin with the most important questions coming up on your screen. This is part A, where it's based on option picking. We'll come to numericals also. Super Sian, don't worry. Starting off with the numerical questions first. Here it comes. Okay, all right. Welcome. Numericals ಹೇಳ್ಕೊಡಿ. Okay, one special session only for numericals ಬೇಕಂದ್ರೆ comment ಮಾಡಿ. I will make a separate session just only on numericals ಬೇಕಂದ್ರೆ, because ತುಂಬಾ ಕಮೆಂಟ್ಸ್ ಬಂದಿದ್ದಾರೆ. ಸರ್ ನ್ಯೂಮರಿಕಲ್ಸ್ ಹೇಳ್ಕೊಡಿ. ನೋ ಇಶ್ಯೂಸ್, ನಾನು ಮಾಡ್ತೀವಿ. ನೀವು ಕಮೆಂಟ್ ಮಾಡಿ. ಅದು ಕಮೆಂಟ್ ಅಲ್ಲಿ you should also make sure that you like that particular comment, so that I get to know, okay, many students are interested in this. Okay, all right. Pakka numerical, yes. Super Chin, maybe after the JEE means, just after maybe some 6 days or 5-6 days or something, just let the JEE get over, because I will be super busy over there also. Okay, because all the discussions I have to only look into. Okay, what is the question for what is the answer for this? Large distance from a short dipole, the electric field depends at the distance from as what? Now, what is the formula? Bega heli, electric field ali. Electric field is either 2 or basically 1 times of K into P divided by R cube. Do you see? Electric field is inversely proportional to R cube, everyone. So hence, what is the answer? Option B is the correct one. Very good. Suma is proud of you, my dear students. Thank you so much. Very good. Keep it up. All right. Moving on. An example for polar molecule: oxygen, nitrogen, hydrogen, H2O. See, polar means the polarities should be separated, positive, negative. Now, if you notice, oxygen, nitrogen, hydrogen, these are all diatomic molecules. So when you have these diatomic molecules, both are same element. If this is element number 1, this is also that same element. Oxygen, oxygen, hydrogen, hydrogen, nitrogen, nitrogen. Then there will be no shift in the polarity. But when you take H2O molecule, when you take H2O molecule, then you will see that this has negative charge, sorry, this has positive charge, this has positive, this has double negative charge. So definitely there is a dipole moment. There is definitely a dipole moment is there. So definitely it is a polar molecule. Hence option D. Yes, very good. Awesome. Cube relation. Yes, Manish Kumar. Very good. Super Shian Sumayas. Awesomeness. Looks like you guys are preparing super well for your PUC. Really proud of all of you. Next question on your screen. The resistance of carbon, the resistor, is this plus minus ohms. the color of the first band of the resistor is. Now actually speaking, the color coding of resistors has been deleted, so technically speaking we should not be doing this question. Okay, sorry for putting up this question, ignore this. Yeah, go to the next question. In case of total internal reflection, okay, then what do you think is the correct option? Total internal reflection, which happens from dense to rare, the light completely gets reflected. Yep. In case of TIR, okay, light rays must be traveling from denser to rarer medium. Angle of incidence must be less than the critical angle. The angle of refraction is 0 when the angle of incidence is equal to the critical angle. What do you think is the correct answer for this? Yes, Santosh, it is deleted, I know. Yeah, what do you think is the correct answer for this? In case of total internal reflection, what happens, my dear students? Well, the correct answer, I think this option did not get completely printed fully. The light should go from dense medium and it should be incident on a rarer medium. Then it will get totally internally reflected. So that is basically option B, I believe. Angle must be less than the critical angle. This is wrong. The word less is wrong. Actually, it should be more. Angle of refraction is 0 when the critical and when the angle of incidence is equal to the critical angle. No, the angle of refraction is 0 is wrong. There is no refraction only. There is no refraction when the angle of incidence is the critical angle. Refraction only doesn't occur. So hence, only B option seems to be correct. Very good. Awesome, Suma, Fidu. Very nice, Yuvraj, Sampath. Awesomeness, Manish. Kudos to all of you. Next question on your screen. Yes, note Kohli. For an AND gate, okay? Which inputs of A and B will give higher output, true output, high, 5 volts, true, 1, whatever you want to call it. Yep, think about it. AND gate, my dear students. AND gate looks like this. You want true over here. True means basically 1. So both should be true. Only then it will be true. So if this is 1, this is 1, only then the output will be true. Yes, option D is the correct answer. Yes, these questions are super duper important for your PUC exams. I don't know how many of you have seen these sessions which I have been conducting. Please watch these classes, guys. See, we have already done. See, Gopika ma'am, top 30 questions. Model paper by Namrata ma'am, top 30 questions we have done last week. So last week we did top 30 question series. Before that we did model papers. And we also did top 100 questions for KCET. Okay, so all these sessions we have been doing. All these sessions. So we started off with model papers. All right. Then we did top 30 questions. And then this week we are doing most important questions. So watch all these classes. This will be very, very helpful for all of you. Okay. Cool. Fine. Let's move to the next question. Davison-Garmer experiment proves what thing about basically electrons or light? Does it talk about light? Does it talk about electrons? Does it talk about the wave nature or the particle nature? See, Maxwell said light is a wave. Einstein and Planck said light is also a particle. So that was Einstein, Maxwell and Planck's. That was all for light. Then came Davison-Garmer experiment using de Broglie's hypothesis. Hypothesis means you think about an idea, but you have not proved it. So de Broglie proposed, and finally Davison experiment was able to prove it. What was it able to prove? That even matter, which is a particle, has wave behavior. So Davison-Garmer experiment proves the wave nature of particles. Using whose hypothesis? Using de Broglie hypothesis. De Broglie hypothesis. Keep this in mind. Wave nature was given by Maxwell, electromagnetic radiation. There is a separate chapter for this. This is nothing but Einstein. He won Nobel Prize for this. Einstein and Planck. Okay, so Einstein and Planck. H, Planck's constant. So that is the particle nature of light. So any of these questions can definitely come. The ratio of nuclear densities are, okay, you don't even have to solve this directly. You can see and answer this particular question. Very direct question, my dear students. Very direct question. Think carefully. What should be the answer for this? nuclear density. The density of nucleus is mass of the nucleus upon volume of the nucleus. Best part, this is going to be a big constant for all atomic mass numbers, for all the elements. Yes, it is the same. Hence, it should be 1:1. Yes, that is the correct answer. Very good, Manish Vidu. Awesome. Great, great, great. Yes, option A. Very good, guys. Very good. Awesomeness. Proud of all of you, Suma. Awesome. Next question. The direction of the current in the loop A, B, E, as shown in the figure, is along AB if it is increasing, along AB if it is decreasing, along ACB. I think it is AB. If I is increasing along ACB, so I is constant. So first of all, current is only induced if what? There is magnetic field which is changing. So magnetic field can change only if current changes. So 100% D can't be the answer because current is constant. So constant current can't induce changing magnetic fields, nor can it induce electricity. Correct? Okay. Now comes the main thing. Which direction is it going to be? All right. So let's say, for example, we take the direction ABC or ACB. So if we want the current to be induced, let's say like this. Okay, if you want the current to be induced like this, take the fingers of your right hand and curl it in that direction. The thumb will come towards you, which means the magnetic field which will be induced will be in this direction towards you. This magnetic field always will oppose the change. So this magnetic field is basically opposing. It is basically opposing. Okay, what might it be opposing? Let's try to think. Now the current here is going like this. So this current, if you hold the thumb like this, the fingers will curl this way. So the magnetic field is going inside. This is the magnetic field due to this wire which is carrying current in this way. This magnetic field is going like this, but the field has been created this way, the induced field. That means it is opposing this because this guy is increasing. So the magnetic field is increasing. So it is opposing it by inducing the field in the opposite direction. This is using your Lenz's law. This is using your Lenz's law. Hence, this magnetic field can only increase if this current is nothing but increasing. So the current increases, then the field will, or the current will be in the anti-clockwise direction, ACB. So current is increasing along ABE, no, along ACB, along AEB basically. So hence option C seems to be correct. A is wrong. Obviously, if A and C is correct, then B automatically will be wrong because current will not be decreasing. It should be actually increasing. Is that clear? So option C seems to be correct, my dear students. Just check this out. Yep, option C. So I'll repeat. Once I get the direction of the induced field, where the induced field will be, it will be always opposing the change. So the original current was creating a field here inside. So it is being opposed this way because inside it is increasing. So it is opposed by inducing the field in the outer direction. Got it? That is the logic behind this question. Very nice question. Okay. Understood, Yuraj? Paka? Okay. Let's do. If the potential difference across a capacitor is doubled, then the energy stored in it is? Well, is there a formula for potential energy stored? Yes, it is half capacitance into voltage square. Now just imagine you are doubling the voltage. So the voltage is doubled. So the square of the voltage will be made 4 times. Capacitance won't change. Number half will not change. So energy will basically become quadrupled, basically 4 times. V square. So if V becomes 2 times, this will become square times 4 times. Hence option B is the correct answer. Is that right, everyone? Got it? Clear? Shall we go to the next question on your screen? Here it is. The electromagnetic waves suitable for radar systems used in aircraft navigations. Is it gamma rays? Is it UV, micro, or infrared? Infrared thermal scanners, right? It is useful for that. Ultraviolet is basically used to desanitize or sanitize things. It is also very harmful. It can be used for certain medical treatments. Gamma rays, extremely powerful, can be used to treat some cancerous cells and all of that. So gamma is very, very dangerous also, and at the same time also useful in some cancer therapy. Microwaves used in microwave ovens and also in radar systems. Yes, direct question. There is one table in NCERT: applications, wavelengths, electromagnetic spectrum, frequency to wavelength. By heart all the applications of all the waves. There is a very likely question either in KCT or in your second PUC. Even in JEE it can come. Okay, very good. A charged particle is moving in a uniform field. The angle between the velocity and field is theta. The trajectory will change. Match the following. This is very direct question. Either you know it or you don't know it. You cannot sit and derive it over there. It will be very time consuming. See, let me tell you. If you throw the charged particle like this, such that the magnetic field is also here, it will continue in a straight line. If you take the charged particle like this, throw it like this, the magnetic field is inside, then the charged particle will go in a circular path, Whereas if you throw the charged particle like this, such that the magnetic field is over here, then the charged particle will go in a path which is circular also, and it is elongated, which is basically nothing but a helix, So from this, it is very obvious which should be the correct answer, my dear students. It is option B. Check this out. One goes with B. So 0 degrees, definitely a straight line. 0 degree straight line. If it is 90 degrees, it has to be a circle. 3 goes with A. 2 with C. Yep. So check this out. If it is 45-degree, basically some angle, it will go in a helical path. So hence the answer is option B. Yep, very good. Proud of all of you. Those of you get the correct answer. Even if you didn't, I hope you now are learning the things. This is very, very important. Okay. All right. The polarity of induced EMF in a coil is given by the polarity of the induced EMF, the direction of the current. Who gives it? Is it Lenz, Faraday, Gauss, or Ampere? Standard law, and that is Lenz law. It is based on energy conservation. Remember that. Energy conservation. So this particular law based on energy conservation tells me the direction of the induced current and electricity. Correct. Very good. In a transformer, the windings of the primary and the secondary coil are wound over one over the other to reduce the energy loss due to what kind of losses are there in a transformer? There are multiple kinds of losses. One is a flux loss, because some flux leaks out to the surroundings. It will not pass through the secondary. Then there is eddy current loss. All right, you laminate the cores. Then you have hysteresis loss. So you use a good ferromagnetic core so that the hysteresis curve is as small as possible, right? And then some of the winding loss is also there. So you use a very good conductor so the heat losses are as minimal as possible. So my dear warriors, from all of this, there is only one option, that is flux leakage. So when you wind it over one another, what happens? The flux hardly can escape out because they are concentric circles. So the field lines will pass through within themselves. So no flux gets lost. Very minimal loss happens. Correct. Next, the corpuscular model of light was first given by corpuscular. Who gave corpuscle? Corpuscle is nothing but the particle of light. It is nothing but the particle of light. Who gave that particle theory of light? Okay, come on. There is Newton's corpuscular theory. Huygens gave the wave theory, not Descartes or Maxwell. Maxwell gave the electromagnetic wave theory. Huygens gave the wave theory of light, but he considered light to be a mechanical wave needing a medium called as ether. Whereas Maxwell said no medium is needed. It can even go in vacuum, and light is not mechanical, it is electromagnetic wave. So it was Newton's corpuscular theory. He assumed light to be particles, wavelengths are different, the size of the particles are different, and all of that. He assumed the particles are elastic in nature. All these things he assumed. A current in a circuit containing a cell and a resistor. Simple circuit is given by, this is very laddu question. Come on, guys. Very laddy question. Yes. Suma, yes, Sir Isaac Newton. Correcto. Perfecto. Come on, my dear students. What is the correct answer for this particular thing? Yep. The answer is I is equal to E by R plus R, because think of it like this. This is the EMF, this is the internal resistance, and this is the total resistance. This is R, this is E, and this is R. So there will be some current, and this current will be obviously EMF by R plus R. This is standard result for a battery connected to an external resistor or a load or a device. Yep, option C. Well, if you ask me what are these then? This will happen, by the way, this will happen when there is no internal resistance. That means it should be an ideal cell. Only then this can happen. Only when this is an ideal cell. When will this happen? This will happen when there is no external resistance. That means you are connecting the wires directly. So you are basically shorting the battery, shorting the cell. Then you will get this formula. This is for your external load with a real battery, non-ideal cell. This is a non-ideal cell or a real cell. Non-ideal cell or basically a real cell. This is the formula. Okay? All right. If you start from now, can you still get 95%? Well, see, I'm not sure whether 95% or not, but 90% for sure. Okay, because 95% requires extra effort. And if you are saying that I'm starting right from zero, then it might be a little bit difficult thing to do. But yes, within these next few days, if you just do those model papers, just practice those model papers again and again and again, and do all the questions that we are doing here, trust me, you can easily get 90%. Also, get all the papers from your friends and your college, what they have been giving. Same questions. Just practice, write it again and again. Don't read it. Don't by heart. Write it again and again. You will get it. Trust me on this within these few days. Okay? All right. Are these any fixed questions for exam? See, most of the questions will be repeated, and whatever we do, no, you will come out and tell me, sir, whatever you told, these questions were repeated. That's what will happen. So that is the whole purpose of these sessions. I want you to come out of the exam hall and tell me, sir, whatever sessions you did, all the questions were just from your sessions. Maybe one, two here and there, maybe from NCRT, this, that. But 99% questions are from your sessions. That is what you are going to tell. That is the reason why we are doing all this. Okay? All right. Okay. Model paper ದಲ್ಲಿ questions repeat ಆಗುತ್ತೆ. Yes, Vidu. Repeat chances ತುಂಬಾ ಜಾಸ್ತಿ ಇದೆ. Because at the end of the day, they cannot invent very new questions. They have already given 3 model papers, plus old model papers are there, PYQs are there. How many new questions can you invent? It will be again same thing, just twist and turn. That's all. The value change ಮಾಡ್ತೀವಿ. That's all. Nothing much. Okay, let's do some filling the blank questions. Filling the blank questions, guys, come on. The words that you have to fill in is mutual induction, inductance, diffraction, magnification, quantization, and interference. These are the first 3 questions. And I think then, oops, sorry, the answer is there on the next. Oops, okay. We'll go to the answer slide on the next one. One of the basic properties of electric charge is, I think this everybody knows. Yep, come on, what is the answer for this? It is nothing but quantization. Is that right? Quantization, very good. Like Q is equal to NE. Q is equal to N times of E. That is the quantization property. The ratio of magnetic flux linkage to the current in a coil. How much flux is linked in a coil? That is basically called as your inductance. Isn't that right? That is nothing but your inductance. Perfect. So inductance is gone, quantization is gone. The principle of working of a transformer. Yes, what is the principle of working of a transformer? You have 2 coils. What do they link with each other? Mutually induct. So mutual induction. So mutual induction should be the answer for this. So this word is also gone, my dear students. This word is also gone, my dear students. Yes, very good. Let's go to the next. Don't see the answers here. A microscope is used to produce large dash of a small object. Large what? Diffraction, magnification, interference. Obviously, large magnification, if I'm not wrong. Large magnification. Yes, definitely that is the correct answer. The phenomena of bending of light around the edge of an obstacle. So if there is an obstacle, the light will bend like this. The light will bend like this. What is it called? It is called as diffraction. It is called as diffraction of light, the bending of light around the edges of an obstacle when the wavelengths are of the sizes of the hole, the aperture. That is, called as diffraction. Very, 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 very good. Awesomeness, guys. Awesomeness. Very good. Great. Let's go to the next question. Answer any of the 5 questions over here. Mention any one. Okay, potentiometer is not there. Let me just remove this particular slide. Yes, potentiometer is not there. Just ignore it. Meter bridge is there. Well, I hope you know what is meter bridge. If they ask a question on meter bridge, definitely you should be able to do it. Yep. Meter bridge is definitely there. Meter bridge is basically there. Meter bridge where you have unknown resistance, known resistance, and basically you have a wire over here. This is a battery, okay, something like this, and you have a galvanometer. It shows null deflection here. This is L, this is 100 minus L, this is known resistance, this is unknown resistance. So X minus R is L by 100 minus L. This is used to find unknown resistance. Unknown resistance. This question can definitely come on meter bridge, and it is based on the Wheatstone's balance. Wheatstone balancing. Wheatstone balancing. Yes, Wheatstone's balancing method. Yes, okay, everyone. Suni, current electricity in numericals, please, sir. It is very tough to solve. Circuit analysis. Okay, fine. Let's do it then one day. Just current electricity questions, no issues. So one day I will plan only numerical questions. Okay, because you guys are all demanding numerical questions. So we'll probably do, if it's a big chapter, then 1 or 2 chapters together. If it is a small chapter, then we'll do 3-4 chapters together. Fine, we'll do that. No issues, Sunil Hegde. Okay, we'll do that. Next question. The expression for gyromagnetic ratio of an electron revolving around the nucleus, and explain the terms. So this is an idea where if you take a charge particle, and make it go around, it revolves, this particular revolution of a charge, this charge flowing in a loop, it behaves, this particular thing behaves like a loop carrying current, like a loop with some current. It behaves as if charge is flowing, a loop carrying current. What does a loop carrying current produce? This loop carrying current will obviously produce its own magnetic field. So even this should produce its own magnetic field, and because of that there will be north pole, south pole, north pole, south pole. That means there will be a magnetic moment. So there will be a magnetic moment. So a charged particle revolving behaves like a current carrying loop, which produces magnetic field and magnetic polarities. Hence it behaves like a magnetic dipole moment. Okay, so this then eventually becomes like a magnetic dipole moment. Yeah, this is north pole, this is south pole, so it becomes like a magnetic dipole. And the formula for that magnetic dipole, m by, remember there is angular momentum over here, is equal to q divided by 2m. This is that formula, and this is called as your gyromagnetic ratio. Gyromagnetic ratio. Gyro means of rotation, magnetic because magnetic effect is produced. So rotating charges producing magnetic moment. That's why gyromagnetic ratio. Magnetic moment by angular momentum is q by 2m. This is the formula. Okay, so that's it. So you can mention m is magnetic moment, L is angular momentum, q is charge, m is basically the mass. Is that okay? Everyone with me on this? Pakka? Shall we go ahead? Pakka? Shall we go ahead? Okay. Okay. Let's move. Let's move. AM receiver, this is deleted. Just ignore this. Done. Okay. State and explain Faraday's law of electromagnetic induction. This I have told 100 times also, that Faraday's law, Lenz's law, Kirchhoff's law, Ampere's law, Gauss law, all these laws, pakka question will come. I'm telling you, I'm leaking the paper now only. So Faraday's law, you can say that this is a law based on, how electricity is induced in a coil or in a loop. So whenever there is a change in the magnetic flux in a coil, you will see that there is EMF which is generated. This EMF which is generated, there is electromagnetic force which is generated. This is called as the induced EMF. So induced EMF is created, and based on the resistance of that particular coil, you will see there is current which has been induced in that particular coil. The exact formula for this is given by the EMF which is induced magnitude wise is nothing but d phi by dt. This phi is magnetic in nature. Where this magnetic flux is magnetic field dot the area vector. And then you can also give some examples. Saying, if there is a coil over here, and if you take a magnet like this, and if you move it, then obviously the field lines through it will definitely change, and there will be electricity generated inside that coil. So you can give some examples of such things. Okay, so basically whenever there is a change in the magnetic flux, then EMF is induced. This is going to tell me that okay, electricity is created, but how much electricity is created is given by that law, that the induced EMF is directly proportional to the rate of change of the magnetic flux. So like you can see, this orange thing is the first statement. It tells me, okay, electricity is created under what circumstance? When there is change in flux. How much electricity is created is given by this particular formula. So these two statements with this formula and this example, full marks you are guaranteed. Okay, is this absolutely understood? What and all points you should write? This phenomena, what it is, the formula and explanation, that rate of change of magnetic flux is induced EMF, and one example by diagram. Full marks guaranteed. Faraday's law explanation. This is not there. Sorry, ignore. Okay, let's go to the amplification and all. The transistors is deleted. Write the relation between magnitude of electric and magnetic fields in a electromagnetic wave with the speed of light, and hence find the magnitude of the electric field and the time if the magnetic field at that point place is 2 into 10 to the power minus 8 Tesla. Okay, read the question. This is a question on basically electromagnetic waves. And they are asking us what is the relation between magnitude of electric and magnetic fields with the speed of light, and also find the magnitude of the field if magnetic induction is given. We all know if light is basically traveling like this, then you have a magnetic field, let's say like this, and simultaneously, of course, you have the electric field which goes perpendicular like this. So the electric field is perpendicular to the magnetic field. That is how it goes. Is that right? Okay, there are two perpendicular waves. And we all know that the electric field by the magnetic field is the speed of light. This is the formula. So write the relationship. This is the relationship. Okay. So now the question is to find the electric field. The question is to find electric field. Electric field will be C into B. C is 3 into 10 to the power 8. Magnetic field is 2 into 10 to the power negative 8. 3 2s are 6. Powers of 10 get cancelled. This will be volts per meter. If you write it and leave it like this, you will fully get those marks. Otherwise, marks will be cut. You can use Newton per Coulomb also. Yes, volt per meter or Newton per Coulomb is also fine for them. Don't worry. Yep. Perfect. Shall we go ahead? All right. Let's go to the next one. Mention three properties of electric charges. How many times I have done this question? Countless. That means this is the most important question of electricity. Electrostatics. So, important properties of charges. First one you can write is that, these charges, basically, you can say they are quantized. Quantization of charges, you can say. Quantization. And you can mention that the net charge is always integer into E. This is basically any integer, and this is 1.6 10 to the power negative 19 coulomb. Charges are always in fixed multiples of quanta of electron charge. Then you can say they are scalars and they can be added or they can be subtracted, as simple as that. So when I find the net charge, it is Q1 plus Q2 plus Q3, like that Qn. Third thing which you can mention is the charge conservation. Charge conservation, saying that if there was a system with some charges before and something happens to the system, the total charge before and afterwards will be the same. So no charge can be destroyed or can be created magically. If it is there forever. Okay. And you can just mention some supplementary properties. The unit of charge is basically coulomb. You can mention that. And a coulomb is basically an ampere multiplied by second. You can just mention it to impress the examiner. And you can also mention it is a scalar quantity. If you mention these things, examiner super impressed. You can start by writing like this. Charges are scalar quantities which are measured in coulombs, where 1 coulomb is an ampere into the second. And following are the properties, most important properties of a charge. 1, 2, 3. Hence, done. Super impressed. And underline quantization. Their addition, subtraction can be done. Conservation. They will be fully impressed. Yep. Yeah. I hope. No, see that what you're mentioning, Manish Kumar, those are the properties of electric fields, not the properties of charges themselves. Electric field properties are there. They cannot form loops where they will start from positive, end at negative. Those are the properties of electric fields. So if that question is asked, there you will mention that. Okay. So here we have some 3 marker questions, my dear students. 3 marker questions. Get ready for it. What is a transformer? On what principle does it work? Mention one loss in the transformer. Well, start off by drawing one simple symbolic diagram of a transformer, which is like this. This you can say is basically the primary. This is secondary. This is nothing but the symbol of transformer. And the principle, what is a transformer? Transformer is used to what? To either increase or to decrease AC voltage. AC voltage. When you increase it, it is called as step up transformer. When you decrease, it is called step down transformer. And transformers are used to basically minimize usually the transmission losses. Minimize usually the transmission and distribution losses. From the power plant to your home, electricity should be conserved as much as possible. So that is why you use a transformer. What is the principle of working? It is based on the principle of mutual induction, which is given by Faraday, basically Faraday. Yes, it is based on the principle of mutual induction. So second mark over here. Next mark, example of one power loss. There are many power losses which happen. One is basically eddy current loss. Second loss You can say hysteresis loss. Hysteresis loss. The third loss that you can mention is the winding loss. Winding losses. And last one you can say flux loss. But you don't have to mention everything because they have asked only one of the losses. Let's say you mention flux loss. Then mention how do you reduce the flux loss. How do you reduce the flux loss? By keeping concentric coils. If winding loss, you mention how you reduce that winding loss. It is reduced by using good conducting quality materials of the wires. Hysteresis loss, you reduce it by using good ferromagnetic material with a smaller hysteresis curve. Eddy current loss. These eddy current losses basically go as heat and they are inside that conducting core, and you reduce it by laminating the core. You mention that, you will be super duper impressing that examiner. Got it? Everyone? Understood? Clearer? Everyone, let me know. Okay, those things only are mentioned. Pure principle of mutual inductions. When AC current flows through a primary coil, it produces a time varying magnetic field. So the magnetic field changes in the primary and that induces electricity in the secondary, and it is based on Faraday's law of EMI. Transformer is a device which transfers electrical energy from one circuit to the other circuit, either step up or to step down the voltage in transmission and distribution systems. All these points I have mentioned. So I'm mentioning these points, I'm showing you the model key also so that it sticks in your head. Write it down, whatever Shreyas Sir is doing here, okay, you have to compulsory ಗೆ ನೀವು yes practice ಮಾಡಬೇಕು. If you just see, no use, you will forget tomorrow. You will get entertained, you will like it, you will understand, but you will not remember. So please, yeah. Okay, all right, moving on. All right, power loss done. Okay, what is a NAND gate? Write its symbol, truth table for at least 2 inputs. Okay, very important question. Again, they can ask you for NOR, they can ask you for AND, they can ask you for NOT. Any gate, truth table, symbol, formula, everything they can ask. So first of all, what is the symbol for NAND gate? This is the symbol. You show a dot because it's a NAND. If N was not there, only AND was there, forget the circle. Let's say these are the two inputs, A and B. Let's say this is the output. This output, you will say A dot B. Dot means and you have to put a not. That's why you put a bar. This is the mathematical symbol. This is the circuit symbol. Circuit symbol. Just say like this. This is nothing but your inputs. This is nothing but your output. That's it. Now you can say 0, 0, 0, 1, 1, 0, 1, 1. 0 and 0, 0. Negation of that 1. 0 and 1, 0. Negation of that 1. 1 and 0, 0. Negation of that 1. 1 and 1, 1. Negation of that 0. So that's your truth table. But they had asked any two inputs, but you can write it like this. Examiner will not cut marks. He will be okay only. Everyone, cool till this point? Understood? Very good, very good, very good. Awesomeness, awesomeness. Let's, yeah, circuit symbol, okay, NAND gate, okay, truth table, okay, perfect. Show that a bar magnet behaves as an equivalent current carrying solenoid. Show that a bar magnet behaves like an equivalent current carrying solenoid. Okay. So basically these kind of questions, my dear warriors. Second. Whenever you have, let's say, a current carrying loop, this is basically your current carrying loop, okay, of some n number of turns, cool. Then if at all, on the axis at a distance of x, if you measure, let's say, the magnetic field, if let's say you happen to measure the magnetic field, you might remember the formula for the magnetic field on the axis of a loop. It was nothing but mu naught into current into r square, where r is the radius of this particular loop, R is basically this particular radius of the loop. The whole thing divided by 2, R square plus X square, this same R square plus X square, whole raised to 3 by 2. This is the formula for the magnetic field on the axis of a current loop. Axis of a current loop. Now, if your axial point is far away, okay, this is very, very important. If axial point is basically far away, what do I mean by that? X is much, much larger than R. Then what will happen? R square plus X square will be approximately equal to, this is very large, this is small, X is much, much larger than R, will be approximately equal to X square only, because the next term will be neglected. So approximately it is X square. So therefore magnetic field will be mu naught I. You have your R square as it is. You have your R square as it is. Okay. Keep this in mind. The whole thing divided by 2 is there. And you have X square only now, because R square plus X square is just X square. Whole thing raised to 3 by 2. But there were n number of terms. Please keep that in mind. So I have to multiply this with n. This also will be multiplied by n. So let's see what happens now. So this will become mu naught I, okay, divided by 2, x raised to 3, and then you have nr square. Now we'll do some magical thing over here. I don't want mu naught, I want mu naught by 4 pi deliberately. So observe now, what will I do? Magnetic field will be mu naught divided by 4 pi. Current is there. Because I put 4 over here, so I have to also multiply by 2. Okay, so I'll put 2 over here, multiplied by current is there. Because I put pi below, I have to also multiply by pi. All right, then this r square is there, and multiplied by n is also there, and the whole thing is obviously divided by x cube. Mathematically nothing wrong. Okay, pi goes, 2 4 goes, becomes 2. Everything else is as it is. Now why did I do it like this? Observe carefully. You know what pi r square is? It is nothing but area. This is current, this is area, this is number of turns. Do you know what that is basically? Come on, my dear warriors. Yep. So I have mu naught by 4 pi multiplied by 2, whole thing divided by x cube, and over here current into area into n, nia, that is nothing but m, which is magnetic moment, my dear students, which is nothing but n into I into a. Oh, this formula is very much similar to, if I take a bar magnet, basically a bar magnet like this, okay, this is North Pole, this is South Pole, it has its own magnetic moment, and then if I go on the axis very, very far away, then at this point, the magnetic field is given by exactly this formula. This means if the formulas are identical and I'm replacing the coil with a magnetic moment, then this coil's formula is very much similar to a bar magnet's formula. Hence proved that a coil with some current in it behaves very much similar to a magnet, to a bar magnet dipole. That's it. So, it is very much similar to it. Is that clear? Yep. Everyone understood? Oh, clear? Oh, awesome. So this is what you should write, my dear warriors. All right. Write the Cartesian sign convention used in analyzing the reflection or refraction It could be for lens also, for mirrors also. Sign convention always same ide. Yes. So you can show maybe a mirror like this. It doesn't matter whether it is concave or convex mirror. The convention will be the same. You can also show something like this. Okay, so you can say this is concave mirror. This is your convex mirror. You can also draw your principal axis. Yes, this is your principal axis. This is your pole. This is your pole. And main thing that you need to mention over here is everything has to be measured from the pole. First point, all distances are measured from the pole. Pole is the origin. Anything above the principal axis is positive. Anything above the principal axis is positive. Anything which is below the principal axis is considered negative. So anything over here will be positive, anything below here or below here will be negative. Okay, that is the second point. Next point, what you will mention is whatever is the direction of the incident ray. So let's say the incident ray is coming like this, for example, from an object, incident ray, or maybe the incident ray is coming like this from some object over here. So this, if it is the incident ray, let's say this is basically the incident ray, then the direction in which the incident ray goes onto the other side, that other side will be positive. So incident rays are going like this. So this side is positive. So therefore, this side will be positive. In this case, incident rays are coming this way. So this side will be positive. Naturally, the other side will be negative. Naturally, the other side will be negative. So this is the sign convention, my dear students. Please mention this properly. Okay, everyone, clear? Pakka? So mention this. If you want, you can give an example also. They have done the same thing, guys. It's not anything different. And all distances are measured from the pole. Show the incident ray. Anything on the top positive, anything below is negative. All distances on the left hand side or one side is negative, other side is positive. So this diagram, if you mention, and the points, if you mention, that's it. Full marks you will definitely get. Next question. Two batteries, internal resistance, are connected in parallel so as to send a current through some resistance. Find the current through the cells and the current through the external resistances. Also, everything you have to find. Okay, how do you basically do these questions? Well, let's start by drawing the diagram first. Okay, two batteries are there. Okay, this is one battery, internal resistance, then another battery, internal resistance. Okay, they are connected to some another resistance over here like this. External resistance 8 ohm. This battery, let's say 4 volts and 2 ohms. This is 6 volts and 3 ohms. This entire circuit can be converted into one simple circuit like this, where you just have one battery, one internal resistance, and one external resistance, of course. So this is 8 ohms. So what is the equivalent EMF of this and this equivalent resistance? So the formulas goes as follows. First of all, the equivalent EMF is E1 by R1 plus E2 by R2. Remember this, upon 1 by R1 plus 1 by R2 for parallel. If it was series, just add them. No need of breaking your head, just add them. In case of parallel only, the formula is slightly weird. Okay, so what is E1? This formula is there in your NCERT also, by the way. E1 is the first battery, which is 6 volt. R1 is that guy's internal resistance. E2 is this battery and that resistance. So 4 by 2 by 1 by this resistance and this resistance, R1 and R2. Okay, 6 by 3 under 2, 4 by 2 under 2. So it will become 2 plus 2. 3 2s are 6. Okay, 3 2s are basically 6. And this will become 2 plus 3, which will become 4 by 5. And that 6 goes on the top. So this will become basically 24 by 5 volts. 24 by 5 volts. Everyone? Yep. Very good. Awesomeness. Very good. Next, what you're going to do, if this is 24 by 5 volts, the next thing that we need is okay, the current, internal resistance. For that, use this 1 by R internal will be 1 by R1 plus 1 by R2. So it will be 1 by 2 plus 1 by 3. So it will be basically 6 by 5. So therefore, R effective will be 6 by 5 ohms. So this will be 6 by 5 ohms. Okay, this was in volts. So now trying to find the current in this circuit. So that current will be EMF, correct? EMF, which is nothing but how much? 24 by 5 by outside resistance plus the internal resistance, which is nothing but 6 by 5. So now do the math, you will get the answer. So 24 whole thing divided by 5. Here LCM 8 5s are 40 plus 6 whole thing divided by 5. 5 5 cancel. So it will become 24 by 46. Now 24 basically goes with 2, it will just become 12, and this will become 23. So 12 by 23 amperes is going through this resistance. So the same current will be going through this resistance. Get it? This is how you do it. This is how basically you will do it, my dear students. Clear, everyone? Yep. Shall we go ahead? Shall we go ahead now? Yep. This is how you do these questions. Okay. Next, mention two uses of Polaroids. Mention two uses of Polaroids. Polaroids. What are these Polaroids? Polaroids. Come on, guys. Light waves chapter. Light waves chapter. Electromagnetic waves are transverse waves, and transverse waves can be polarized. They have a direction of oscillation. So if an unpolarized light falls on a polarizer, then all the other oscillations get cancelled. Only that pass plane will allow those oscillations in its direction, and the light will get polarized. And the oscillations are unique in one particular direction. What are they used for? Polarizers. One, they are used basically to, uh, you can say, prevent those reflections from snow, desert, water. They are used in goggles. So Polaroids, you call it, polarizing goggles. So they, avoid as many reflecting surfaces light as possible. So your eyes are protected and you don't feel that glare. So one uses in Polaroid goggles, correct? Yep, definitely. What are they also used for? They are also used for, sometimes determining some samples in virology lab, bacteria lab. Yeah, they are used for determining some samples. Sometimes they use it for determining how the virus is, the shape, the size, and all of that as well. They are also used in organic compounds analysis. Yeah, there are many organic compounds. When polarized lights pass, they can, rotate that light. They can be used to determine the type of chirality and all of that. So used for analyzing some organic compounds as well in chemical laboratories. Definitely. Yep. And because of their uses in chemicals, sometimes most of the oil paintings and paintings which are there, because they are usually organic, sometimes inorganic in nature. So because they are made of oils and all of that, so they can be also used to determine and analyze the paintings which are there. No, not laser beams also, you can say. Laser beams are also polarized in nature. Yep. Yes, you can say that, Manish Kumar. Okay, so laboratory analyze the plane polarized light, shape of viruses, improve contrast in oil paintings and all that. Okay, all these are the explanations for polarizers. A parallel beam of light is incident on the face of an equilateral prism, and by rotating the prism, the angle of minimum deviation is measured to be 40 degrees. Determine the refractive index of the material of the prism. If the prism is immersed completely in water, calculate the new angle of minimum deviation. See, first thing is very simple. The parallel beam of light is incident on an equilateral prism. That means angle of prism is 60 degree, because it is mentioned equilateral prism. All angles will be 60 degree. The angle of minimum deviation is measured to be 40 degree. The angle of minimum deviation. So delta minimum is basically 40 degree. Determine the refractive index. There is a direct formula. Mu is equal to sine of A plus delta minimum by 2 by sine of A by 2. Everything is known, just substitute it over here. So sine of 60 plus 40 by 2, the whole thing divided by sine of 60 by 2. So this will be sine of 50 degrees divided by sine of 30 degrees. Okay, so sine of 50 is basically, I don't know, just leave it like that. Unless log books are given, we cannot do it. Sine 60 by 2, which is sine 30. Sine 30 is half, so 1 by 2. So it will become 2 on the top. So 2 times of sine 50 will be the refractive index. Will be the refractive index of the first case. Second time, if it was immersed in water, then what is the nu deviation? So basically, you will have mu relative now, mu relative, which will be this refractive index of that lens or that prism, of that particular prism, upon refractive index of, what is it, water, refractive index of water, and this will be then equal to sine of A, angle of prism still remains 60, minimum deviation I do not know, whole thing divided by 2 by sine of angle of prism divided by 2. So now you just substitute everything over here. Refractive index of the prism is 2 times of sine 50, 2 times of sine of 50 degrees, whole thing divided by refractive index of water 1.33, which means 4 by 3 is equal to sine of 30 degrees plus delta minimum by 2, whole thing divided by sine 30. Sine 30 is basically half. Yes, and then rearrange this, and then you will get delta minimum from here. Use log books to solve this. You will have to use log books to solve this, because sine 50 value, you can only find it in the log book. Same thing over here, while doing the calculations, you might need some log book. So I think in the calculation part also, that would have been done. Yep. So sine 50 through logbook is 0.766. They have found the refractive index to be 1.532. Then they have found the relative refractive index, correct? And again, they have used the same formula and solved it to get the answer to be 70.4 degrees. Yes, you have to use the logbooks. Without that, you cannot do it. Okay. Perfect. So that's the session, my dear students. I hope you enjoyed the session. We solved many important questions. We are revising the concepts. Every time you are seeing some repeated concepts, and many new things are also coming up. This will cover up your entire syllabus slowly. So please be attentive, watch the lectures and practice all the questions handwritten. Don't just watch it, also rewrite it. Okay. Thank you very much. Stay subscribed. Smash the like button if you have not liked it yet, and share this video with all your colleagues, your friends, your batchmates, so that they also, become better person. Don't be selfish, don't be conjuice. Please share it. Okay. Thank you very much. Bye bye. Cap to Shreyas Sir signing off.